Hi everybody, here we're going to go over the instructions for the Ohm's Law lab. So you have your instructions here. There's parts 1 and part 2. And if we zoom out, you'll see it's going to be the same experiment just done on two different websites. So this is going to be part 1 and this will be part 2. It's the same type of data taking but just done on two different websites. The first website, the circuit is given to you. You can see it here. And on the second website, you'll have to you have to build a circuit yourself and then repeat the experiment. So let's go ahead and go to the first website. So if you click here on the first link A, so this is the website that's going to come up. And so what you're looking at here, you have a power supply. That's going to be the battery. You can adjust the kind of battery or the voltage in the circuit. And next you have a resistor. And you can adjust the resistance in the circuit by just clicking on these bands here. So, and the other thing is, so those are the main components, and then you have the probes. You have an ammeter here connected in series. And then here you have a voltmeter connected in parallel across the battery. So in this experiment, what you're going to do is, you're going to keep the resistance constant, so at a particular value, and you're going to leave it that way for the entire experiment. Make sure that you don't refresh the page, because, let me just refresh it here. If you refresh the page, you notice that the resistance changes. So you're going to keep the resistance constant for one trial. And what you're going to do is you're going to adjust the value of the battery voltage. And as you do, you're going to read the corresponding current and the corresponding voltage. So if I click on battery B, you're going to read the current and the voltage. And you click on battery C, you're going to read the current and the voltage. So here there's something to notice. If you notice, the current reading didn't move here. And the reason why is that the scale here is not low enough. So there's arrows, there's a green, there's these up and down blue arrows here. So if either the scale is at the minimum value, the needle is at the minimum scale, or at the maximum value, you have to adjust the scale. In this case here, the scale is, the reading is actually, well, it's at the minimum, so I want to reduce the scale of this device to figure out what current this is actually reading. So you just click the down arrow, and you see the scale change, it becomes smaller, until you get a non-zero value. So here it looks like these are different readings, but if you actually calculate those scales, so here for example, this looks like it's about 1, 2, 3, 4, 5. So this is about 1.5 milliamps. So if I go to the next scale, now this is on a scale of 20, but now let's see what this is. This is going to be 2, 4, 6, 8, 10. So again, this is about a little less than 2, so this is still about the same reading here. It's just that you're reading the same value, but just on a different scale. And the same thing is going to apply for the voltage. So here, for this voltage, if I want to, let's look at it on two different scales. So probably, let's pick another value, let's pick another battery. Okay, so let's pick this one. So let's look at it on this scale. On this scale here, the voltage reads 2.5 volts, and let's go to this scale. So here, it looks like it's a different reading, but if you notice, now this is going to be 2, 4, well, actually it's 1, 2, 3, 4, 5. So here this is 1, 2, 2.5. So they both read 2.5. So these up and down arrows, you're going to have to, what you'll have to do is whenever the reading is at either a maximum or minimum value, you're going to adjust the scale in order to get the best possible reading. And the best possible reading is always the one that has is the lowest scale, so you can get the biggest number of sig figs. So for example, for this voltage here, this scale is too big. So let's go to another scale. So here this is 2.5, that's okay, but I would recommend reading it on this scale here, because there, well, here it's going to be the same in both cases, but there'll be other cases where, well, it's always best to read the scale on the one that has the most amount of sig figs. So here this would be 2.5 volts. So now let's go. So that's going to be that's the basic introduction to the circuits. You have your battery, you have your resistor, you have your ammeter, and you have your voltmeter. And whenever you make a reading, make sure that if you have a scale that's at a maximum value, so let me just go to this one. So if you have a scale that's at a maximum value, just adjust the scale so that you can get either a value that's in between the two highest and lowest tick marks. All right, so that was an introduction to the circuit and how to record the readings. So let's go down to the instructions and see what else we're going to have to do. So don't forget to, well, here, the errors, these are going to be for for the part 2 of the lab. So we'll come back to these later. So the first part of the experiment just goes over that, what I just discussed about how to adjust the scales in order to get the best possible reading. The actual experiment is going to start on section 7. So here's a picture again of that circuit diagram that we looked at, the one that's already prepared. So in section 7, what you're going to have to do is, so you can see here, there's 3 trials. There's you're going to measure resistance, 3 different resistances. And so you record the resistances over here. So for example here, RTL1, that's going to be, if you go to the website, the resistance that you calculate from these color bands, that's what you're going to record over here for your theoretical resistance. And now what you'll do is you're going to select battery A and measure the corresponding current and voltage. So you'll click battery A, measure the current, measure the voltage. And then you're going to click on battery B, measure the current, measure the voltage. So battery A, corresponding voltage, and then corresponding current. And then battery B, that corresponding voltage, and then that corresponding current. And you're just going to complete this table. And don't forget to put the units for actually here for battery name is battery name, the voltage in a circuit, current, and resistance. So don't forget to select those units. And you're just gonna now change to another resistor for the second part. So in this first simulation here, all you have to do is just click, just modify any of the color bands. And then so this is going to correspond to another resistance. And then you'll, whatever this resistance, whatever you calculate based on these color bands, then you're going to record that resistance over here and then repeat the experiment. And in part 3, you're going to get another theoretical resistance. So go back to the circuit and you can just click, you can either just refresh the page, and now you have a new resistance, and do the same thing. Measure the current and voltage for battery A. So here this is a minimum scale, so I should increase the scale to get a non-zero reading. And so you measure the current and voltage and then put it over here, or voltage and then current, and then complete this table. So that's going to complete the data taking section for this setup here. So what you're going to do next is you're going to create one graph, and on that one graph you're going to plot voltage on the vertical axis and current on the horizontal axis, because what we're verifying today is Ohm's law. And Ohm's law is a relationship that tells you that in a certain limit called the ohmic limit, voltage is proportional to the current if the resistance is constant. In this case here, the resistance is going to correspond to the slope of the graph. So if you plot voltage on the vertical, current on the horizontal, you're going to get you should get a straight line, and the slope of that straight line is going to correspond to the resistance in the circuit. And each of these trials here that you just done, you're going to put all of them on the same graph. So you should have three lines and 3 slopes. And once you've gotten those 3 slopes, then you're going to record those 3 slopes over here. So the first one, 0.78, and the second one, 0.64, and then the last one, 0.24. And the last thing you'll do is you're going to calculate the percent error between, and so these slopes here, what they correspond to is your experimental measurement for the resistance in the circuit. So the slopes are going to correspond to R experimental. So the next thing that you'll do is you're going to calculate in this column here the percent error between the experimental slope, which is going to be this one here for resistor 1, and the theoretical slope, which is going to be this one over here for resistor 1. So you'll calculate the percent difference between those two and you put it there. And then you'll also calculate the percent difference between the theoretical and experimental slope, experimental resistance for resistor 2 and then for resistor 3. And that's going to complete part 1 of the experiment. So part 2 of the experiment is the same setup. It's just that you're going to have to build the circuit yourself. So you'll take this circuit to be your model. And in part 2, you're going to go to the link B here. And then you're going to build the circuit yourself. So you'll put your power supply, your wires, resistors, voltmeters, ammeters, and you'll assemble it so that it looks like this circuit over here. And then next you'll take a screenshot, and then you're going to paste a screenshot at this location. So you'll put your battery, your wires, resistors, ammeter, and voltmeter, and you're going to assemble them so that they look just like this circuit over here. And once you've created a version of the circuit, of this circuit onto the simulation page, then you're going to take a screenshot of that circuit and you're going to place it over here in section 10. And then after that, you're going to repeat the experiment. So I'm just going to make a simple circuit here, just to kind of get some readings. I don't recommend that you do it this way, but it's just to get some readings. You'll have to build a circuit yourself to make sure that you have all the correct connections. But once you have the circuit set up, what you're going to do is, so you can see this experiment, it's the same data, but here you're given the voltages, and also in the instructions you're told what the resistances you're going to set your circuit to. So you're going to set your resistance to a particular value given in I guess step number 5 in the experiment, and then from that value then you'll go to the table, and you can see here you're given a set of voltages, so you're just going to adjust the voltage and measure the corresponding current. So first of all, given let's see here, this resistance, you're going to put that over here as your theoretical, and I guess it's 42.5. And so then you set your voltage to 10. And then you're going to measure that corresponding current. And then after that, you're just going to repeat it. You're going to change the voltage to 20, and then you're going to fill in this table here. And don't forget the units. And then the next experiment, you just go back to step 25, and it tells you what what your new resistance is going to be. So you'll just adjust the resistance, and then repeat the experiment for this is going to give you R theoretical 2, and then adjust the resistance again to another value, to the last value, and that'll give you R theoretical 3. And then you'll complete this table here. And this is the table in section 11. And then just like before, you're going to make a graph of voltage versus current. And then from that graph, you're going to get 3 trend lines and 3 slopes. And you'll record those 3 slopes over here. So 0.78 all the way down to the 0.24. Here you're also going to calculate the resistance, the error in the resistance. So what you'll do is you go back to the computer simulation, and now the ammeter, the voltmeter, you're gonna take these to be your digital readings, and you're going to record the error of these 2 devices up here in section 1. So these are going to be the resistances, the errors for the three devices. So these are going to come from the second link, the FET website. You record those errors there. And then once you've recorded the error for those three digital devices, then you'll use this equation here to calculate the error for the slope. And then you record that value over here, or the error for the resistance. So, and you record, that's going to be down here, and you record the corresponding error for the resistances. And that's going to be using, again, this formula over here. So all you need is the error in a voltage and the error in the current, and then you can use that to get the error in the resistance. And then just like before with the last one, you'll also calculate the percent error between the slope here, that's going to be your experimental resistance, and this resistance here, which is going to be the theoretical resistance. And then that's going to complete the experiment part. And then after that, you'll go to the homework sheet and complete the homework assignments.